Chocolate fermentation, from bean to bar. Chocolate is so readily available and widely loved, but have you ever stopped to think about how it's made? It starts with cocoa powder and cocoa butter, but how are these ingredients produced? You might be surprised to learn it is reliant on fermentation. It all starts in Mexico and South America with a Theobroma cacao tree. Large pods are cut from the tree, and they are initially sterile, but once they are opened up to reveal the beans, microorganisms present on the outside of the pod have access to the bean. These organisms are things like lactic acid bacteria, acetic acid bacteria, and yeast, and they will carry out the fermentation. The bean is covered in a white, slimy-looking pulp, or mucilage, that is rich in sucrose and pectin. These are the main substrates for fermentation. The ferment uses boxes at varying heights with drainage. To start things off, the beans are piled up in the highest box and it is covered. These initial conditions are anaerobic and acidic and are great for yeast. The yeast have pectinolytic enzymes to break down the pectin in the pulp, and they will also break down sugars for metabolism, producing ethanol. Every 2 days throughout the ferment, the beans are stirred and moved to a new box, making the conditions increasingly aerobic and less favorable to the yeast. During the first stages of the ferment, biochemical reactions that cause browning of the bean also take place through the release of reducing sugars. There are two main reactions. Firstly, sucrose is hydrolyzed to glucose and fructose, and secondly, anthocyanins, a naturally occurring purple food pigment, are digested by glycosidases. As aeration increases in the pile of beans, yeast activity declines and LAB begin to thrive. They will also use sugars from the pulp to create lactic acid, and they can also utilize the ample fructose in the environment as a terminal electron acceptor. As more pulp is broken down, even more aeration is achieved, and acetic acid bacteria can thrive. This marks the start of the end of fermentation. The AAB will of course produce acetic acid, which in simple terms kills the bean and prevents germination. Germination would result in the bean using chemicals that are important to flavor development as metabolites, so although bean death may sound negative, it is favorable for a tasty, quality chocolate product. In the end parts of the fermentation, there are oxidative enzymes that will oxidize polyphenols like catechins from the bean. This is less about color, but more about the flavor, as polyphenols are bitter, so this step reduces bitterness in the final chocolate product. At the end of the ferment, the beans will be cut open, and they should no longer be purple in color, but instead a deep red-brown. They will also be very moist, so they must be dried to prevent mold growth. This can be done in the sun over 5 to 10 days, or with a mechanical dryer. They can be roasted too, which helps remove the outer shell layer, revealing cocoa nibs. These are then ground into cocoa mass, which can be finally sent through a hydraulic press to separate cocoa powder and butter, our desired chocolate-making ingredients.